Welcome to IT Fundamentals, Chapter 1, Episode 1. Today, we kick it off with understanding a few terms. Welcome to the first episode, Chapter 1, Episode 1 of the IT Fundamentals course. Today, we're going to take a look at just the simple basics and get us going. We're going to look at Chapter 1, Page 1, and we're going to look at the core hardware components. We're going to go through on that very first page and that second page, understanding what each one of these items, the terms, if you will, the terms description, the objectives here are going to be that we're going to cover in this chapter. So why is it important that we take a look at this first? Is first that you need to understand what some of these things are at a very basic level before you even start reading the book. You understand what RAM actually means, random access memory, and we'll go over that in just a moment. We also understand that these are absolutely the bare bones fundamentals, so they allow you to start off. If you understand these things, it's kind of your vocabulary list. If you remember from back in your grade school days, this will allow you to understand the very basics as you launch in. So let's get started on page 1, chapter 1, core hardware components. Now, I'm going to go right down this list that's in your book. It's in the Cybex book, so that you can understand what we're talking about here at a very high level before we launch in. So first of all, illustrate the basics of computing and processing. Input. Input means anything that you input into the computer. It could be via audio. It could be the keyboard, the mouse, very simple commands that you enter into the computer, or very complex commands. Anything that you tell the computer to do. I'm famous for saying that computers are absolutely dumb devices. And that's still true, even with the artificial intelligence and machine learning functions. The hardware themselves cannot do anything without some sort of input by a piece of code, by a human interaction, whatever the case may be. So whenever you take your mouse and you move it on the mouse pad and it causes the little arrow to move across your screen, that is an input. All right, so now we're going to look at processing. So behind every single computer is a processor. We'll get to in this chapter where we talk about the CPU, or the central processing unit. And essentially what this is a very large calculator that takes all of the input from the code and the different functions and mathematically mathematically works it to present you a graphical interface. And so processing is the behind the scenes that goes on. And you can think of it this way: your brain, when you are thinking about something, before you take an action, your brain is thinking about something and how you want to do that action, or how you want to go about that. Well, that is processing at its very, very basic form. Okay. The next one is output. Well, output is the result of processing. So you can see how these all work together. You have to do something to input into the computer. Once you input it into the computer, then the computer processes it and it presents an output. So the one thing that you're most familiar with, output, is what's on your screen, whether that be on your cell phone, on your computer, whatever the case may be. All of that is the output. We used to, back in my day, take a piece of paper from a printed dot matrix printer and say, look, this is output. Well, you're absolutely correct in that, but those are days long gone. And right now, output is still just anything that comes out of the computer, whether that's on your screen or in paper format, and so on and so forth. All right, let's take a look at section 1.5, comparing contrast common units of measurement. Now, if you're one of those folks that thought, once you left high school, you never have to deal with math again, I'm one of those. I famously told my algebra teacher I'll never have to deal with math once I leave. I was wrong, and hopefully she's not watching this, but I was wrong. So what do we want to take a look at are storage units. And so let's think about these. Storage, first of all, is where you potentially store output. So an input will occur, resulting in a processing, resulting in an output, which could be either viewed and then thrown away up on a screen, for example, and thrown away, or stored for future use. And when you store that, you're storing it in a storage unit, just like you would think that you're taking junk from your house and you're putting it into a storage unit down at the local garage or whatever. Same thing. But inside these storage units, they're measured by various ways and functions. So first of all, we want to take a look at bit, B-I-T. And we don't want to confuse that with byte, which is B-Y-T-E, which is another one that we'll take a look at. But let's take a look at bit first. So when we say I want a bit of something, you're just wanting a very small piece. And a bit is, in fact, from the perspective of this book and the training that you need, the smallest unit of measurement in regards to computing and storage and processing and things along those lines. So it is a small digit, and it's a small binary digit. So if you think we'll get into that whole binary thing at a later point, but binary being ones and zeros and the powers of 10 and so on and so forth. But the bit, the BIT, is the smallest unit. You can always remember that because you want just a bit of bread or a bit of the candy bar instead of a large amount. All right. So then we move on to the byte. Now, a byte is a grouping of bit in a unit format. So usually in eights. So it's 8 bits. A byte is 8 bits. All right. So you think of it this way. You want something that's really small. You just want a bit of it. But if you want a whole byte, it takes 8 bits to make a byte. So you can nibble it. That's a bit. But if you nibble it 8 times, it becomes a full byte. I bet you remember that one. So then we move up to what's called a kilobit, or KB. It's represented by KB, and that is 1,000 bytes. You can remember that by the word kilo, K-I-L-O is 1,000. So kilobyte, 1,000 bytes. And it's actually 2 to the power of 10. And so that's where the binary aspect, everything with binary is in tens. And so you're looking at 2 to the power of 10 when you're talking about that. Next one on the list is megabyte, MB. And that is roughly a million bytes, or a million bytes, but 1,000 kilobytes. So that's a 2 to the power of 20. So you can see how these numbers are increasing roughly in the thousands range. Gigabit. A gigabit is 1,000 megabytes or thereabouts, 2 to the power of 30. Then you get to the TB, or the terabyte. That's 1,000 gigabits. Now, just to kind of give you an idea, when we get into the terabytes and the PB, which is a petabyte, what we're talking about here is 10 terabytes could allegedly hold the entire collection, if it were digitized, of the Library of Congress. Now, if you've ever been to Washington or any other government area and you've seen the size of the Library of Congress, it is absolutely massive. And if everything is digitized in there, they estimate it's only 10 terabytes worth of digitization that would occur. So PB is not peanut butter, it's petabytes. That's 1,000 terabytes, roughly speaking. And that's just to kind of wrap your mind around the size on that, is the 500 pages of printed material. I'm sorry, 500 billion pages of printed material, if you will, is 1 petabyte. So 1,000 terabytes, which is 90,000 terabytes greater than the 10 terabytes that would take to cover the, I'm sorry, it's 990,000 terabytes bigger than it would take to digitize the entire Library of Congress. That's a petabyte. So you can actually digitize the Library of Congress many times over inside of a petabyte. And believe it or not, we have petabytes and petabytes and petabytes worth of storage out there these days. All right, let's move on to processing speeds, also related to math. There's MHz, which is megahertz, which is 1,000,000 cycles per second. So when we're talking about the CPUs, we talk about how many megahertz they are. There's a 10 megahertz and so on and so forth. That's 10 million cycles per second. That's 10 million math computations per second that are going on, if that were the case. Then we have gigahertz, which is obviously a step up, basically 1,000 over the megahertz type of things, and it's millions and millions of cycles per second. And you apply those to RAM and CPU and other types of GPUs, which are graphical processing units. All right, section 2.3 of this chapter will explain the purpose of common internal computing components. And so we're going to look at motherboards or system boards. And if you think of that, that is the typically green board that you solder all the CPU, the RAM connectors, and GPU memory, graphical cards too, and so on and so forth. That's essentially the interface where everything comes together for the computer. And the way I like to describe that is, especially if you look at it, it is like the boundary of a city plan, and you can see all the little roads that run inside that. There's a great picture of an entire motherboard or system board that's inside of this chapter here for you to take a look at. If you want to flip over there right now, it's figure 1.1. And if you look really closely, you can see lines, and those lines almost represent streets, and you can see different components that are on that board that you could think of almost as representing buildings on the block, if you will. So that motherboard system board is essential for everything else that we're talking about, the RAM, the CPU, the GPU, and all that kind of stuff, in order to communicate. All right. And then we have what's called firmware or BIOS, and that is the very basic, going back to what we talked about initially, input. It's a very basic input that the computer receives. BIOS is basic input output system. And it really can do nothing or very little except for manage the components that are on the motherboard and get the system up just to the very basic components in order for it to receive more input from an operating system like Windows or Linux or something along those lines. So that's firmware and BIOS. Then we take a look at what's called RAM, or random access memory. And this is typically what we call memory. And when we're talking about trying to speed up our computers and make them faster, this is typically what people talk about, is they're going to add memory or going to add RAM to the system. RAM is typically a temporary memory system. And what happens and how that interacts with the central processing unit, or the CPU, which is the very next thing to take a look at here. So we can now talk about these together. The CPU is the math processor. It's the brain, if you will, in there. The RAM or the memory is a temporary storage unit where the processor will run those mathematical computations, and it will set it aside in the RAM, so that if that same function is asked or called for again, it will call it from the RAM instead of the CPU as an already processed unit, and therefore it won't have to take the time or the energy to process the unit the second time. So it pulls it faster from RAM. So when you're using a product like your email program, like Microsoft Outlook, and there's repetitive functions inside of that, it will store that in RAM. If you're using Photoshop and you're creating an image or something, it will store a lot of the preloaded, if you will, the preloaded input that the CPU generates whenever the software piece is started up. It will put that in RAM so that it doesn't have to regenerate that later on. Makes things faster. All right, so we just talked about the RAM, the CPU, and now we're going to talk about something called ARM, or Advanced RISC. And RISC is itself an acronym. So the Advanced RISC Machine. And Advanced RISC Machine, we'll talk about that, but it's basically a function like a CPU that allows for faster processing. We'll talk about how these tie into mobile phones and tablets. We know what mobile phones are. Probably every single one of us has a mobile phone. You may even be able to listen, or maybe in the process of listening to this podcast on your mobile phone. So that's your iPhone, your Android, and then the tablets are like your iPads and so on and so forth. Now, well, the other thing we're going to talk about is 32 versus 64-bit. So remember, I told you a bit is the smallest unit, a single binary digit, if you will. Well, 32-bit and 64-bit are bigger units that are associated with that don't quite reach up to that byte level. And so we're going to talk about how those work with laptops and workstations, and why you might want to use a 64-bit over a 32-bit. But that gets into some detail. We'll talk about that in there. GPU, or graphical processing unit, is a special CPU that is designed and configured to work specifically with graphics cards. Now, this is what makes your gaming systems faster. When you have all those motion going around inside of the multiplayer units and flight simulators and things along those lines, or if you're using it more for business purposes, if you're using Photoshop, you're using illustrative type of products, it will be able to compute those more efficiently and effectively, because the graphics themselves create a significant amount of processing requirements, and believe it or not, generate those GPUs generate a massive amount of heat. And so the GPUs are quite important for people who want to do graphics, video, things along those lines. All right, we talked about storage a little bit. We're going to dive into the difference between a hard drive and an SSD. The hard drives are usually what we define as the spinning disk drives. And that's kind of like an old record player, if you will. We'll get into that, versus the SSD, which is solid state drives, which is a static memory chip that you utilize. We're going to talk about the importance of cooling and how that increases the performance of the computer. You know, I work in the data center environment, and we keep two key factors inside the data center is our humidity and our temperature. We keep the humidity down because the moisture can create additional static, and if you get too low, it even creates more static. So we want to keep the moisture level or the humidity level roughly 40 to 50% inside of the data center, and we want to keep the cooling down at around 65 to 75 degrees. In order to ensure that these systems run most efficiently. So we'll get into talking about that a little bit. A NIC is not a friend of yours. That's short for Nicholas. It is a network interface card. So network interface card could be a physical thing you plug into, so you have a wired network, or it could be a wireless network. You have a Wi-Fi card. And then we'll talk about whether we have those onboard or offboard, meaning on the motherboard system board, or if there's separate cards and the advantages of that. All right, section 2.5, we're going to compare and contrast different storage types. So we're going to look at volatile versus non-volatile memory. And volatile memory is the kind where, when we're talking about RAM, where the volatile will be lost whenever you shut down your computer. It means that, you know, it has some sort of characteristics where it requires power to maintain it. So that's typically your RAM. And then non-volatile memory is where it won't be lost typically when you shut down your computer. So you're talking about hard drives and SSDs when you talk about non-volatile memory. We're going to look at local storage types. Again, we're going to look at hard drives and the spinning disks versus the SSD. We're also going to look at optical drives, or CDs, compact discs, DVDs. Those are the old spinnies that you can use as a mirror, and they write data to them, and flash drives, which are very early type of format of solid state drives, really, because what they are is they're a single memory chip, usually 8, 16, 32 gigabits that you can place in your computer, and they're mobile, so you can move them around. Optical drives are also mobile. All right, well, I hope that has given you a little bit of an overview of what you're going to learn. So this is day 1, and I look forward to you coming back tomorrow, where we will dive in, and we're going to, if you want to dive ahead and take a look at things, we're going to look at the first 7 to 10 pages of the book. And we're going to look at introducing internal components. We're going to talk about that motherboard or that system board a little bit, and different functions with that, the chipsets, and we're going to just go right up to page 10, and we're going to end at processor sockets. So we're going to understand those kinds of things in segment or episode 2. I look forward to talking to you or working with you. Again, if you did not understand any of this kind of stuff right off the bat, shoot me an email, and I will dive down on the things that you need to understand better. This was pretty basic stuff. One thing, other than just understanding what the acronym means, is probably okay. Certainly, I should say it's okay, because we'll understand that better as we go through these pages of chapter 1. So if you're not getting the fact that, the power, 2 to the power of 10 is with your kilobytes, don't worry about that part. Just remember that it's a kilobyte is what a KB is. Perhaps the next layer up, where you look at the fact that it's 1,000 bytes. You know, a megabyte is 1,000 kilobytes, and things along those lines. So I look forward to working with you more, and let's get this and nail it down. Thanks.